Okay, good afternoon, everyone. Okay, now is the second or third lessons, okay, of gas law, right? And in the previous lesson, we have discussed example 4.3 about the Boyle's law, one of the example of Boyle's law. However, the other, we haven't answered all the questions yet. However, the other part are related to the experiment itself, which we couldn't perform by you in a small group. And so we can only discuss the precautions and the procedures through the textbook. And that's why I asked you to bring the textbook. And now please please turn to page 144. 144. Right? 144頁啊，呢度啊 experiment 4.1 in this one experiment 4.1. Okay. Where the setup is simple, we make use of a syringe connecting to a pressure sensor with a tube, a plastic tube. Okay, and then we press the syringe inside, press the gas in to increase the pressure, and then we take the readings, and then we pull the syringe out, okay, to increase the volume, and we can observe a decrease in the pressure by the pressure sensor, okay, which can be read directly, all right? However, there are points to be noted. So please pay attention to the precaution and discussion of this particular experiment, which should have been arranged and performed by you in a small group manner, okay? So first questions, the rubber tubing should be short. Why? Why? Okay. So first of all, this is the syringe. With marks marking the volume relative to the position of the piston. However, it is connected to the pressure sensor. Like this. Then we have a rubber tubing. Okay, the idea is that the volume read or the volume shown at the body of the syringe, this one 10 centimeter, 20 centimeter, or 30 centimeter, the volume of this part only, not including this part. So the longer the tube connecting the syringe and the pressure sensor, the higher the error in this reading, because this reading does not contain the volume of the gas inside the tubing. And so the rubber tubing should be as short as possible. That's the reason behind question 1, right? And if you have question to ask, please do so. 呢個管咧入邊咧有氣體嘅，啲氣體個 volume 咧係冇度到嘅。呢個 volume 咧，呢啲 volume 淨係度呢一度到呢一度嘅啫。呢個圈住嘅咧就冇數計嘅，度唔到嘅個 volume。 咁所以咧嗰個 rubber tubing 要短啲，咁嗰個 volume 咧就準確啲。個 rubber tubing 越長咧 ，the longer the rubber tubing，OK，the larger the error in the measurement of the volume，right？ 好啦，第二 ，connection should be airtight。咁啊點解咧？咁啊嚇，咁sealed或者係搽啲 Vaseline 咧，即係一啲係ointment 咁樣嘅嘢啦嚇，攝住嗰啲罅咧，等啲氣體唔可以走入去。OK 啊，咁因為咧，我哋呢啲 laws 咧，全部嘅前提係咩咧？啊，全部嘅前提咧就係 fixed amount、fixed mass 啊 of gas 啊。咁如果咧我哋嗰個唔係 airtight， 我哋拉嘅時候或者褪入去嘅時候，或者空氣可以走入去或者走出嚟嘅話咧，我哋呢個理論咧就唔準確㗎啦。我哋個理論嗰個基礎咧就係 fixed amount of gas、fixed mass of gas。Okay， so it must be airtight. No gas leaks in and no gas leaks out. Right？ 好啊 ，Number 3, push the piston and repeat step 2. Why must we push the piston gently and slowly? Gently and slowly. Why? Why? Because another condition for Boyle's law is constant temperature. So I guess most of you have the experience of pumping a basketball, for example. Okay, or pumping a bicycle. Even though pumping a bicycle or pumping a basketball is not 100% completely analogy to this case. However, the idea is this: if we push the pistons very quickly, for example, the gas will have a response to have a rise in temperature. At the same time, when there is a rise in the pressure, and so that in order to keep the temperature as a constant, we push it slowly and gently, and any increase in the temperature will have a time to radiate or to conduct some energy to the environment so that the temperature of the gas could remain constant throughout the experiment. Okay? Otherwise, if we push it too hard and too fast, the temperature of the gas may rise. As you can find that when you pump a basketball quickly, okay, the pumping pistons usually will get warm, right? And lastly, do not hold the syringe too long with your hands, right? Because once again, same idea, constant temperature. If you are holding the syringe, then your body temperature, which is about 36.5 degrees Celsius, which is in some cases and many cases hotter than the gas inside the syringe. And so some of the energy will go into the gas because you have direct contact with the gas. Now you are holding the syringe, right? And so the temperature of the syringe of the gas will rise accordingly. And that is not desirable. This is not desirable. And so we will not hold the syringe for a long time, okay? In order to keep a constant temperature for Boyle's law, all right? So these are the points to be note, okay, about this experiment number 4.1 for Boyle's law. And now we go back to example 4.3, and the answers for A2 should be like this. The readings, the pressure reading is slightly higher than expected. State 2 possible reasons. Okay, one reason is that the error due to the rubber chippings. Okay, because the volume inside the rubber tubing of the gas is not count. And Secondly, due to the small gap between the pistons and the syringe, some gas may leak out. Okay, when you push the syringe inside or pull it outside, and some gas may leak in. Okay, and so the mass of the gas is not a constant. And then part B, when the piston is released, it tends to go back to its original position. Explain briefly why. Explain briefly. Okay, now that the piston is in the horizontal direction, right? So if the pressure now is, for example, is higher than the pressure of ATM, then what will happen? When it is released, then the outside pressure is ATM, and so it will come back to the position in such a way that the pressure inside is equal to the outside. Okay, because if the pressure inside the syringe is larger than atmospheric pressure, it will expand automatically to reach the equilibrium that the pressure at both sides of the piston is equal to each other. All right, and that's why the piston tends to go back to the original position. Okay, please look down at these points. They are not easy to understand in the first place, so please do have some revision. All right. And the next law is called pressure law. Okay, the next one. Well, in this case, we keep V constant. Okay, and we perform experiment which can show you that the pressure of the gas is directly proportional to its temperature in Kelvin scale. So we have P is directly proportional to T, and the equation to be used when we introduce two states of the same gas, we have I suppose you have learned variance in mathematics, right? Variance 個正比反比嗰啲學咗嘛，係咪？正比反比學咗。呢個咧同 T 咧就成正比咁所以咧我哋將呢個掉過嚟啦。P over T 咧就等於一個叫做比例常數啦 ，proportionality constant。咁如果你有兩個 state 咧，就寫成 P1 over T1 equal to P2 over T2。不過咧個 remark 就係個 temperature has to be in Kelvin scale。If you use Celsius scale, you got a wrong answer. All right? 瓜係點樣咧？瓜係 P directly proportional to T。If it is in Kelvin scale, then it will be something like this. Okay? A straight line pass through the origin. And because pressure and temperature are directly proportional to each other. Okay? Okay, then I guess we can go through experiment 4.2 on page 147 first, before we go into another example. Okay, this one, experiment 4.2, this one. Okay, on page 147. We use a water bath. Water bath. 即係用一個大嘅 a large beaker fill it with water and then immerse a glass a conical glass of gas inside and then with a tripping, okay, and then with a tripping connect to the pressure sensor. Then we heat up the water bath at different temperature, and then we take the take the pressure, okay, with the pressure sensor, and so we can find P and T, okay, various sets of data of P versus T in Kelvin scale. So first of all, if it is in Celsius scale, degree Celsius, then it will be something like this, okay, which does not pass through the origin because at 0 degrees Celsius, the Kelvin scale is 273, right? And this is the experimental result. And how we come to the point that the 0K is minus 273 degrees Celsius because of graph like this. We plot this graph and then extend it backward. And we discovered that, okay, not just one, but with many, many different scenarios, different experiments. We can draw the same conclusion that this line will pass through this point, minus 273 degrees Celsius. And so we find out that which is a very particular, very special temperature. And so we choose it as our 0K. And move this vertical axis to this point. Then we have a directly proportional scale, okay, which is our Kelvin scale. All right. 好，咁我哋討論下嗰個實驗下面嗰啲 precaution 同埋 discussion 先，好冇？啊，呢度咧因為冇辦法安排實驗啊，所以亦都係要大家即係多啲去思考啦嚇，係難處理嘅呢啲嚇。通常依家喺學校就會做實驗俾你睇，或者安排俾你做啦，係咪？咁但係冇辦法啦，我哋即係都要教嘅，係咪？嚇，得唔得？啊，即係又唔可以停喺度，係咪？啊，得唔得？好啦，我哋睇下 precaution 嘅 discussion。We have to heat the water gently and keep stirring it. Why? 個重點係咩咧 ？Stirring it。因為做實驗咧，加熱要好慢，好慢咁加熱，唔可以好快。咁咧要搞住佢。好啦，咁點解咧？咁樣嚇 ，OK？ 咁呢啲咧，嗱，實際問題咧，實際解決。因為問個實驗嘅咧，一定要知道實驗點做，就從翻個實驗嘅 setting 咧去答呢個問題。咁咧，首先咧要知道咧，我哋用一個 large beaker fill up with water， 係咪？咁咧就擺嗰個 flask 落去啊，然後咧個 tripping， 個 tripping 做嗰個 pressure sensor 啊，咁呢度咧就 Bunsen burner 啦 ，heating up 啦，咁呢度咧另外仲有thermometer 啦。OK， 好啦，咁加熱點解要慢咧？咁樣啊，咁啊因為咧嗰個 gas 咧就係現嗰個 flask 啦，喺個 flask 入邊咧呢啲 gas 咧就浸喺啲水度啊嘛，係咪？咁啊，如果呢個加熱好快啊 ，if this is heat up very fast, then perhaps this part of the water will be 80 degrees Celsius, while this part of the water is only at 45 degrees Celsius. Just for example, if it is heated very, very fast, perhaps at some instance, the temperature around the flask is not uniform. Then the temperature, the thermometer should be inserted into the empty flask, okay? Not at this point. So this opening is quite complicated. We need to insert another thermometer, okay? In some scenario, we will use two thermometers. One to measure the temperature of the water, the other to measure the temperature of the gases inside. However, we will follow the setting of the textbook where we have only one thermometer. Okay. Beaker large beaker 下面嗰度咧，仲有個圓揼揼嘅嘢咧，就係嗰個 stirrer 係攪住啲水嘅嚇，得唔得？係攪住啲水嘅。OK， 好啦，咁所以咧，我哋咧就要攪住啲水，慢慢加熱。點解咧？就希望咧，因為咧呢個實驗其實就好難做嘅，好難做。因為咧嗰個 empty flask 咧就好輕啊，佢擺落水咧就有 buoyancy， 就有浮力。個浮力咧就好大嘅，咁佢成日咧都會即係令到佢即係彈起嘅，咁所以咧就唔容易即係 fix 嗰啲嘢嚇，佢唔好穩定嘅OK， 咁我哋搞佢咧，令到佢成個水咧呢一度，如果呢一度係 say 我哋度到56度，咁我希望呢一度咧呢度上面高啲咧，起碼都係有55度啦，係咪？我點樣可以做到咧 ？How to achieve this？Heat it up slowly， 跟住咧就有個 stir 攪勻啲水佢係嘛？令到呢一度大家咧都有 same temperature 先得噶嘛，係咪？呢度係嘛 ？OK， 咁如果 temperature 唔一致嘅話咧，咁咧我哋實驗就完全唔準確噶啦。OK， 得唔得？好啊，咁所以咧加熱要慢啦，又要 stirring 啦。第二嗰個 rubber tripping 咧 should be short。Why？ 咁我哋頭先都答過啦，係咪？咁但係咧今次咧嗰個原因同之前就唔同喎，因為之前咧我哋就要度嗰個 volume change 啊嘛，係咪？我哋要 measure the volume 啊嘛。咁今次我哋唔使度嗰個 volume 咯喎，因為個 V 咧係 constant 喎，係咪？不過我哋想咩？我哋想個 T 咧係uniform everywhere 係嘛？好啦，呢度咧都有啲 gas 喎，個 T 係幾多度咧？係咪？譬如你加熱到呢度咧，個水係 say 60 degrees Celsius， 咁喺呢個 rubber tripping 呢啲 gas 係幾多度咧？喺呢度幾多度咧？喺唔同嘅點咧，個溫度都可能唔同嘅喎，因為個 rubber tripping is not immersed inside the warm water bath， 因為始終咧最後尾咧嗰個 rubber tripping 咧都要離開個水面先可以 connect 到去嗰個 pressure sensor 噶嘛，你唔可以成個浸晒落水嘅，係咪？呢個嘢唔係 waterproof 嘅喎，係嘛？你唔可以成隻嘢浸晒落水嘅喎，得唔得？咁呢個喺個空氣嗰度喎，喺氣體嗰度，咁所以呢一堆咧如果呢個係60度，可能呢一度咧即係剩翻50嘅啫喎，可能呢度咧剩翻40嘅啫喎，可能呢一度咧就 room temperature 嚟嘅喎，係嘛？所以呢一度嗰啲氣體咧越長嘅話咧，佢個溫度嘅 variation 咧，我哋就冇辦法照顧㗎，咁個 error 就越大啦，是係咪？ 好啦，咁啊第三點啊 ，the air in the flask should be dry. Why？ 好啦，點解要乾咧嚇？乾咧就好重要喎嚇，因為咧，如果個humidity 太高咧，咁其實即係代表咩咧？咁樣嚇，即係如果好凍嘅時候咧，咁咧佢就會condense 啦，係咪？咁 condense 咧就影響咗個渦輪啦，係咪？啊，咁咧又或者咧，佢係好濕嘅話咧，咁咧嗰個vapor 個 water vapor 咧，即係咧就會咧影響咗嗰個結果嘅嚇，佢有嗰啲 water vapor 啊 ，OK 啊，咁啊，因為 water vapor 咧就譬如凍嘅時候佢會 condense 啦，係嘛啊，咁就會影響咗我哋嘅結果啦嚇 ，OK 啊，因為我哋唔係做一個溫度啊嘛，我哋做咧就係幾個唔同嘅溫度嘅嚇 ，OK。好啦，第四點啦 ，there is heat loss to the surrounding. Does it affect the result？ 好啦，呢度咧就有 heat loss。to the surrounding， 咁啊會唔會影響咗我哋嘅結果咧？咁樣啊，我哋使唔使揾啲嘢包住佢咧？咁樣嚇 ，OK。3、2、1，答案咧就係唔需要嘅嚇，就 not necessary， 佢唔影響我哋答案嘅呢度啊。咁因為咧，其實我哋呢度咧係不停咁加熱嘅，不停有 heat 咧走入去噶嘛，係咪？最重要咧就係我哋達至一個 uniform temperature。即係點點嘅溫度咧都一樣，咁咧就最好啦。OK 啊，咁咧就最好啦。啊，得唔得？好，咁就呢度咧，我哋要注意嗰啲地方啦嚇。咁我哋去睇一個例題啦。咁啊又係啦，個例題咧就 involve 呢一個公式啦。啊，咁就通常咧就 give you 3 of them。咁啊要 find the fourth one。第二咧就係呢個公式咧就係 symmetrical about right hand side to the left hand side, and that's why we don't need to change the unit immediately. Okay, if the units given are the same, we can use them directly. 得唔得？好啦，咁我哋咧就睇睇148 example 4.4。佢就話 the gas pressure in a tire 喺條車胎入邊啦。Before a trip is 281 kPa, and the temperature is 11 degrees Celsius. After the trip, the temperature of the tire is 34 degrees Celsius. What is the gas pressure in the tire then? Assume the thermal expansion of the tire is negligible. 好啦，咁啊最後尾嗰句講咩咧嚇 ？thermal expansion 啊，咁就因為咧如果嗰個胎受熱咧，佢係會膨脹嘅話咧，即係啲塑膠會膨脹噶嘛。咁個 volume of the gas 咪增加咯，係咪？咁 volume of the gas 會增加嘅話咧，咁呢個 V 係 constant 咧，呢個條件咧就唔成立啦。咁呢個 pressure law 咧就唔成立啦。所以佢要成立嘅話咧，通常係講緊啲咩咧？譬如嗱，你依家買一罐汽水，任何嘅汽水罐裝嘅冇開到，咁你擺落個雪櫃嗰度，咁個汽水個頂嗰度咧有少少氣體㗎嘛，係咪？係嘛 ？OK， 咁佢咧就會凍嘅時候咧，嗰個壓力咧就會減低㗎。OK OK， 但係咧因為有個罐喺外面包住嘛，個渦輪係唔會改變㗎。又或者調轉你喺嗰個雪櫃攞一罐汽水出嚟擺喺度，冇飲曬太陽曬佢1個鐘頭 ，OK 好啦。咁你曬咗佢1個鐘頭之後咧，嗰個汽水嗰個溫度就會增加咯，係嘛？因為佢 fixed volume 啊嘛，個 pressure 就會增加啦，係咪？因為嗰個罐裝汽水嗰個罐咧，一係就爆啫，如果唔係佢就唔會 expand 啦，我當佢唔會 expand 啦，係咪？ 好啦，咁你曬咗1個鐘頭之後，你開咧就好玩啦，係咪？因為個壓力好高啲咧，啲氣水就會噴晒出嚟咯。OK， 咁呢個係你日常生活可以檢視到嗰個pressure law 嘅其實。不過咧就冇辦法做好精確嘅 measurement 實驗室有個 pressure sensor 先做得到。OK， 咁 anyway 咧，佢俾啲咩資料俾我哋咧？咁我哋寫低佢先嚇。好啊。咁我哋咧就有 P1、T1、P2、Q2。Two state, 4 physical quantity, 4 figures。咁啊，第一個咧就係210 kPa。嗰個 temperature 咧就係11 degrees Celsius。好啦，咁 temperature 2咧就係34 degrees Celsius。呢個咧就係呢個。好啦，咁喺呢度咧，請大家記住一點。我哋嗰個公式咧就係對稱嘅，所以可以寫成對稱咧，有一個條件嘅，其實就係嗰個 temperature scale must be in Kelvin。如果你依家唔轉個 scale 咧，咁樣寫，咁咧就錯晒㗎啦。因為一定要用 K 咧。你先可以寫成呢個樣㗎。如果你用 C 咧，一定要加翻一啲嘢㗎。因為咧，其實咧佢唔可以寫成呢個樣嘅。呢個係一條straight line with definite y-intercept 㗎。咁你個 y-intercept 係0，即係呢個係 directly proportional， 一定要用 K 嘅。咁所以咧第一件事咧。其他啲 unit 你唔好理佢啦，譬如個 volume， 特別係 volume 嘅轉咧好難轉嘅。個 volume 咧你可以唔轉嘅話唔好搞佢啦。但係 temperature 一定要轉到 K，OK？ 所以 T1 咧即刻寫plus 273。This is a must，OK？ Okay, plus 273. Okay, 273. And then put all the figures into this equation.所以咧，最後尾個 P2 咧就係唔係增加咗好多㗎咋，增加咗少少啫，304 kPa。304 kPa。好啦，咁樣咧喺呢一度咧，我就當個 kPa 咧，我哋個 K 咧就冇代落去喎，個 K 咧個 K 冇代落去喎，得唔得？呢度個 K， 咁呢度咧個 unit 咧有翻個 K 就得啦，所以呢度仲有 kPa 嘅 ，OK。好啦，咁我哋咧就講咗兩個 laws 兩個 gas law， 第一個就係 Boyle's laws 啦，係咪？咁做實驗嘅時候咧，要注意嗰個 rubber tripping 啦，因為佢度個 volume 嘅時候咧，我哋要度咩PV 啊嘛，係咪？度個 volume 嘅時候咧，喺個 Boyle's law 咧，嗰個 series 嗰個數值咧就冇個 tripping 嗰個 volume， 咁你咪有量度嘅 error 啦，係咪？咁第二咧，我哋 constant temperature 同埋 constant mass，OK？ 你要 constant temperature 就要慢慢推佢。第二隻手唔好揸住個 syringe 揸住太耐，因為你咧就將啲 heat energy 咧就 put into 嗰個 gas 佢就會temperature 會上升啦，得唔得？咁呢係你要注意嘅地方啦。好啊。咁第二個咧個實驗咧就係咁樣做啦用個 water bath 包住佢。最重要嘅咧個重點咧就係 keep 嗰個 uniform temperature。要做到呢一點咧就唔容易嘅喺實驗嗰度，你個 Bunsen burner 個 temperature 好難控制嘅咁你用 Bunsen burner 咧其實通常都係 overheating 嘅某啲 point 咁你要慢慢加熱，慢慢加熱。OK， 仲要咧搞下佢，等到咧全部個溫度咧比較均勻。啊，第二，你總有啲地方咧 ，there are some place that temperature is not uniform。邊一度咧就係個 tripping 嗰度，所以 tripping 都係越短越好嘅，因為個 tripping 唔同位置咧，個 temperature 一定唔同嘅喎。呢度 room temperature， 譬如20度、27度、25度，咁一路慢慢增加嘅話，最多嚇，去到呢度先有60度，譬如咁樣啦，係咪？啊，咁所以個 tripping 咧要短啦，係咪？啊，得唔得？好啊，咁至於其他嗰啲 minor points、minus 嗰啲 points 就比較 minor， 呢啲係最重要。好，咁我哋用個公式嘅時候咧，咁記住 temperature 一定要用Kelvin scale， 一定要用 Kelvin scale， 咁你嘅計算咧先至係啱嘅。如果唔係咧就係錯嘅。咁個計算咧通常都唔係太複雜。好，我哋今日咧就暫且到呢一度，咁啊祝大家中秋節快樂啊！大家就溫習咧用多啲書先嚇，書後面有好多 exercise， 大家要自己要做咗先，好嘛？我哋稍後咧翻嚟再傾啦。OK， 好 ，see you next lesson。好，拜拜。